Forget the pyramids for a moment. Forget the pharaohs, the gods, the golden masks. If you really want to understand ancient Egypt, you have to stop asking what they built and start asking what they built it from. Because here is the uncomfortable truth. A civilization officially described as technologically primitive chose materials that modern engineers would still approach with caution. Not because they were easy, not because they were abundant, but because they behaved in very specific ways. Stone was not just stone to the Egyptians. Material was not neutral. Matter had properties, and those properties mattered. And nowhere is this more obvious than in the very first material people think they understand. Limestone. At first glance, limestone seems ordinary, soft compared to granite, common along the Nile, easy to quarry, the perfect choice for a civilization without iron tools. That explanation sounds reasonable, until you look closer. The limestone used in Egypt's most important structures, especially at Giza, was not random rock pulled from the nearest hill. It was selected, graded, and positioned with intent. The core blocks of the Great Pyramid alone number over 2 million. Each one weighs several tons, and yet they are fitted so precisely that in many places you cannot slide a sheet of paper between them. No mortar holding them together, no glue, no correction layers, just stone touching stone. That level of precision is not accidental. It requires intimate knowledge of how limestone behaves, how it fractures, how it compresses, how it settles over time. Because limestone is deceptive. Yes, when freshly quarried, it is relatively soft. But as it ages, it hardens. Moisture evaporates. Crystalline bonds tighten. The stone becomes denser, stronger, more stable. In other words, limestone improves with time. Now ask yourself something simple but unsettling. Why would a culture obsessed with the afterlife choose a material that transforms over centuries? Why not brick, which was cheaper and faster? Why not sandstone, which was easier to shape? Because durability was not enough. They needed predictability. The limestone from the Tura quarries, used for the outer casing of the Great Pyramid, was nearly pure calcium carbonate. Its reflective quality was so high that, when new, the pyramid would have appeared bright white, almost luminous under the sun. Not symbolic white. Physical white. A structure that reflected heat, resisted erosion, and maintained its geometry across millennia. This was not decoration. It was engineering. But here's where the story deepens. Limestone is not just geological. It is biological. It forms from compressed marine organisms, shells, skeletons, microscopic life. Which means its internal structure is layered, crystalline, and responsive to pressure. Under stress, limestone distributes force in predictable patterns. It absorbs vibration differently than granite. It behaves almost like a natural shock absorber when arranged correctly. And the Egyptians arranged it very, very correctly. The pyramid's internal layout, ascending passages, relieving chambers, voids, works in harmony with the limestone core. Stress is redirected downward and outward, away from critical chambers. This is not guesswork. Modern simulations confirm it. So here's the question that changes everything. If the pyramids were merely tombs, why build them like load-optimized structures? A tomb doesn't need to survive earthquakes. A tomb doesn't need to manage internal stress for thousands of years. A tomb doesn't need mathematical precision at a planetary scale. Unless the structure itself mattered more than what was placed inside it. And limestone was only step one. Because wherever limestone reached its limits, wherever pressure became too great, wherever precision mattered too much, the Egyptians did something strange. They stopped using easy stone, and they brought in one of the hardest materials available on Earth, transported from hundreds of kilometers away, carved with impossible accuracy, placed only where it absolutely mattered: granite, which raises a disturbing possibility. What if the materials of ancient Egypt were not chosen by convenience, but by function? What if each stone type played a role? Not symbolic, but physical. If that's true, then limestone was not the star of the show. It was the foundation. And what comes next is where the real mystery begins. If limestone was the foundation of ancient Egypt, then granite was its declaration of intent. Because granite is not a material you choose lightly. It is not forgiving. It is not cooperative. Granite resists. It resists cutting. It resists shaping. It resists time itself. And yet, across ancient Egypt, granite appears again and again. Not randomly, not decoratively, but precisely where failure was not an option. This alone should stop the conversation. Because, according to the standard narrative, Egypt worked primarily with copper tools. Copper, on the Mohs scale, is vastly softer than granite. In modern terms, it's like trying to cut reinforced concrete with aluminum. You don't get clean cuts. You don't get flat surfaces. You don't get right angles. And yet the granite blocks inside the Great Pyramid are cut flatter and squarer than many modern stoneworks. Some joints deviate by less than a fraction of a millimeter. That is not craftsmanship. That is process control. Most of Egypt's granite came from Aswan, more than 800 kilometers south of Giza. The Aswan quarries are still there. You can still see tool marks. You can still see unfinished projects, most famously, the unfinished obelisk, weighing over 1,000 tons. And this is where the mystery deepens. Granite is not just hard. It is crystalline. It is composed largely of quartz, feldspar, and mica. Quartz, in particular, has a property modern science calls piezoelectricity, the ability to generate electrical charge when subjected to pressure or vibration. Now pause. The Egyptians did not know this term, but they did not need to. They worked with the behavior of materials, not the language of science. Granite responds differently to stress than limestone. It does not flex. It does not absorb vibration easily. It reflects and channels force, which makes it ideal for one thing: stability under extreme load. Look at where granite is used: the king's chamber, the massive beams above it, the sarcophagus itself. Not the outer casing, not decorative halls, not common spaces. Granite appears where structural integrity is critical, where collapse would be catastrophic. The ceiling of the king's chamber alone consists of enormous granite beams, some weighing over 60 tons. Above them are multiple relieving chambers, designed to divert the pyramid's weight away from the room. This is not symbolic architecture. This is stress engineering. And then there is the sarcophagus. It is carved from a single block of granite. Its interior corners are sharp. Its walls are flat. Its dimensions are precise. Even today, reproducing it would require powered tools and controlled environments. Yet, there it sits, unfinished, lidless, embedded within the chamber as if it was placed before the pyramid was completed. Which raises a quiet but devastating question. What kind of planning assumes millimeter-level precision before construction begins? Granite also appears in temples, obelisks, and statues, always where longevity and exact geometry mattered most. Obelisks, for example, are not just tall stones. They are monolithic granite needles, balanced on small bases, surviving earthquakes and millennia of weathering. Granite allowed this because it does not erode evenly. It maintains its shape. It holds its edges. But again, why granite? Why transport it hundreds of kilometers, float it down the Nile, raise it with unknown methods, and carve it with impossible accuracy? The simplest answer is often the most uncomfortable one. They understood it, not theoretically, practically. They knew how granite behaved under force. They knew how it responded to vibration. They knew how to exploit its strengths and avoid its weaknesses. This was not trial and error. The scale is too large. The margin for failure too small. Granite was not used everywhere, only where its properties were required, which implies choice, and choice implies knowledge. By now, a pattern is emerging. Limestone for mass, absorption, and aging stability. Granite for strength, precision, and load resistance. Two materials, two roles, and the Egyptians combined them seamlessly. But stone was only part of the equation. Because there is a material even more revealing than granite. Not because it is hard, but because it should not have survived at all. A material so fragile that most ancient cultures lost it entirely. And yet in Egypt, it endured. Gold. And what gold reveals about ancient Egypt may be the most surprising of all. When people think of gold in ancient Egypt, they think of wealth, masks, jewelry, treasures sealed in tombs. But that interpretation is modern and deeply misleading. To the Egyptians, gold was not valuable because it was rare. It was valuable because it did something. Gold does not corrode. It does not oxidize. It does not decay. To a civilization obsessed with permanence, that mattered more than beauty. Gold was the closest thing they had to a material outside of time. And this is where the story shifts from stone to something far more subtle. Because gold in ancient Egypt was not used the way later civilizations used it, as currency or ornament. It was used selectively, strategically, and often in ways that seem excessive, unless you understand the logic behind it. The Egyptians called gold the flesh of the gods. Not metaphorically, functionally. Gold reflects light in a way no other metal does. It conducts electricity efficiently. It is malleable to the point where it can be beaten into sheets thinner than human hair. Egyptian craftsmen mastered this. Gold leaf found on statues, coffins, and ritual objects is astonishingly uniform, sometimes less than a micron thick. Achieving this requires not just skill, but an understanding of material limits. Why go to such extremes? Because thin gold behaves differently than solid gold. It becomes reactive to light, heat, and subtle environmental changes. It amplifies presence. It transforms surfaces without adding mass. In other words, gold was not there to make objects heavy. It was there to make them active. Look at where gold appears, not in everyday tools, not in common architecture, but on objects associated with transition, death, rebirth, ritual, and divine contact. Sarcophagi, statues of gods, ritual masks. The most famous example is the funerary mask of Tutankhamun. Over 10 kilograms of gold, shaped with precision that rivals modern metalwork. But here's the overlooked detail. The gold is not thick. It is layered. Gold sheets over a core, bonded without modern adhesives, following contours perfectly. That is not decoration. That is surface engineering. Gold also appears mixed with silver in a naturally occurring alloy called electrum. This alloy has a different reflectivity and conductivity profile than pure gold. The Egyptians did not treat electrum as inferior. They used it intentionally, especially on pyramidions, the capstones of pyramids and obelisks. placed at the highest point, exposed to sunlight, reflective across long distances. Ask yourself something uncomfortable. Why place conductive, reflective metals at the apex of massive stone structures? Why not stone? Why not paint? Because metal interacts with light and energy differently. And then there is another metal that rarely gets attention: copper. Copper was everywhere in Egypt, not just for tools, but for ritual instruments, mirrors, and architectural fittings. Copper conducts electricity. It responds to magnetic fields. It reacts with the human body. Modern science understands this. The Egyptians did not have to name it. They observed it. Copper tools were often dismissed as primitive, but copper's softness is also its strength. It can be reshaped, repaired, and reused endlessly. It does not shatter like iron, and copper dust mixed with abrasives can cut stone far harder than copper itself. This is not speculation. Experiments have shown that copper, combined with sand rich in quartz, can cut granite with surprising efficiency. The Egyptians understood composites. They did not rely on one material. They combined properties: gold for permanence and surface behavior, copper for interaction and adaptability, electrum for reflectivity and balance. This is not how a culture uses materials randomly. This is how a culture uses materials deliberately. And now we arrive at something even more fragile than gold. A material that should have vanished completely. A material that decays, burns, and disintegrates. And yet, in Egypt, it survived for thousands of years, preserving words, formulas, and knowledge long after the voices that spoke them fell silent. Papyrus. And what papyrus reveals about ancient Egypt has nothing to do with writing, and everything to do with control. That is where we go next. Stone was built to last. Metal was shaped to endure. But knowledge is fragile. And that is why papyrus may be the most revealing material used in ancient Egypt. Because papyrus should not exist anymore. It burns, it rots, it dissolves in water, it tears easily. Most ancient civilizations lost their written records almost entirely for this reason alone. And yet Egypt did not. Thousands of papyrus texts survived. Administrative records, ritual formulas, medical instructions, astronomical observations, spells, measurements, lists, not myths carved into stone, but operational knowledge. This is where the story changes. Because papyrus was not chosen because it was convenient. It was chosen because it was controllable. Papyrus is made from the papyrus plant, layered, pressed, and dried in a precise way. The fibers interlock horizontally and vertically, creating a flexible but stable surface. But its true advantage is not durability. It is modularity. Papyrus can be rolled, stored, copied, rewritten, transported. Stone is permanent but immobile. Papyrus is fragile but mobile. The Egyptians understood this trade-off, which is why they split information across materials. What needed to last forever went into stone. What needed to move, adapt, and update went onto papyrus. This is not accidental. It is information architecture. Look at what was written on papyrus. Not royal propaganda carved for eternity, but instructions. Medical papyri describe surgeries, diagnoses, and treatments with clinical clarity. Astronomical texts track cycles, decans, and timekeeping. Mathematical papyri show fractions, geometry, and practical problem-solving. This is not mystical rambling. It is applied knowledge, and papyrus allowed it to be used, not worshipped. Even more revealing is how papyrus was used. Texts were copied again and again, errors corrected, layouts standardized, Scribal schools trained generations to reproduce information accurately. This requires something modern societies take for granted, but ancient ones rarely achieved. System continuity. Papyrus made Egypt adaptable. While monuments stayed fixed, knowledge flowed. And here is the unsettling part. The dry climate of Egypt preserved papyrus far better than most regions, but that alone does not explain its survival. Papyrus scrolls were stored intentionally, in jars, in sealed chambers, in protected spaces. They were curated. Someone decided what should be preserved and what could be lost, which raises an uncomfortable question. What didn't survive? Stone gives us theology. Papyrus gives us operation. But papyrus also disappears more easily, which means the most advanced, most sensitive, most dangerous knowledge would never be carved into stone. It would be written and later removed. Papyrus is temporary by design, and that may have been its purpose. A controlled lifespan, long enough to transmit, short enough to erase. Now think about this in context. A civilization obsessed with eternity still chose a medium that decays. Why? Because not all knowledge is meant to last forever. Some knowledge is meant to be used, not remembered. And papyrus sits at the intersection of permanence and impermanence. It is the material of administrators, engineers, physicians, and priests, not monument builders. It is where systems lived, and systems are more powerful than monuments, because systems can be restarted. Stone cannot. Papyrus allowed Egypt to function as a machine, not just appear as one. Which brings us to the final material, one that seems insignificant, one that barely survives, one that is rarely discussed. Pigment. Color. Because color is not decoration. Color is instruction. And what the Egyptians did with pigments suggests they understood chemistry at a level that still confuses modern science. That is where this journey ends. In color that refuses to fade. Stone gives structure. Metal gives permanence. Papyrus gives movement. But color gives instruction. And this is where the material intelligence of ancient Egypt reaches its most unsettling level. Because Egyptian color was never decoration. It was chemistry. Look at the walls of Egyptian tombs and temples. The reds are still red. The blues are still blue. The yellows still burn with intensity after 4, sometimes 5,000 years. Most ancient pigments should be dust by now. But these are not. And that alone should make us pause. Because pigment is fragile. Light destroys it. Moisture destroys it. Time destroys it. Unless you know exactly what you're doing. The most famous example is Egyptian blue, the first synthetic pigment in human history. Not discovered by accident, not found in nature, but manufactured. Egyptian blue is a calcium-copper silicate, created by heating silica, copper compounds, lime, and an alkali flux at precise temperatures. Too cool, and it fails. Too hot, and it degrades. This is not primitive trial and error. This is controlled chemical production, and it gets stranger. Under visible light, Egyptian blue looks calm. Decorative, ordinary. But under infrared light, it emits a strong luminescence. In modern terms, it is infrared active, which means the Egyptians accidentally, or intentionally, created a pigment that responds outside the visible spectrum. No one noticed this until the 21st century. Let that sink in. For thousands of years, walls quietly emitted signals no human eye could see. Why make such a pigment? The official answer is aesthetic. But aesthetics do not require synthetic chemistry. Symbolism does not require temperature control. Function does. Color in Egypt was codified. Red was not just red, It meant energy, chaos, power. Green meant regeneration and life. Black meant fertility and transformation. White meant order and purity. But here's the crucial detail. The meaning of color did not come from belief. It came from behavior. Green pigments were often copper-based, interacting with air and moisture. Black pigments were carbon-based, absorbing light and heat. White pigments reflected light and resisted decay. The symbolism followed the physics, not the other way around. Color told the initiate how a space behaved. Tombs were not painted randomly. Colors were placed deliberately in specific chambers, on specific walls, at specific heights. Some rooms are vibrant, others are intentionally muted. Why? Because color affects perception. It changes how light moves, how heat accumulates, how space feels. In narrow corridors, darker pigments reduce reflection. In open halls, lighter pigments amplify light. In ritual chambers, blue and green dominate. Colors associated with depth, water, and transition. This is environmental design, not art. And the pigments themselves were engineered for permanence. Ochres bound with organic binders. Carbon blacks that do not fade. Copper greens stabilized against corrosion. Blues fused into crystal structures that lock color at the molecular level. Even today, conservators struggle to replicate them. Which brings us to the final realization. Every material choice in ancient Egypt followed the same logic. Stone where mass and time mattered. Granite where stress and precision mattered. Metal where interaction and permanence mattered. Papyrus where systems and control mattered. Pigment where perception and behavior mattered. This is not a culture guessing its way through history. This is a civilization that understood materials as tools, not just resources. They did not build monuments and then decorate them. They engineered environments. And once you see that, everything changes. The pyramids stop being tombs. Temples stop being shrines. Paintings stop being stories. They become components. Parts of a system built from stone, metal, fiber, and color, designed to endure, to function, and to influence long after the builders were gone. And the most unsettling question remains. If we are still standing inside their materials, how much of their system are we still standing inside too?